Rocket Lab, Past, Present and Future. Introduction. Rocket Lab, an influential entity in the aerospace sector, has transformed from a modest startup into a leading provider of launch services. This report delves into the company's journey from its inception to its aspirations for the future, highlighting key milestones, current achievements, and future projects. Past. Founded in June 2006 by Peter Beck in New Zealand, Rocket Lab initially concentrated on advanced space systems and gained prominence through its Electron launch vehicle. The company successfully launched over 80 sounding rockets, making history in 2009 as the first private company to reach space from the Southern Hemisphere. The announcement of the Electron program in July 2014 marked a significant step toward catering to the burgeoning small satellite industry. A cornerstone of this program was the development of the Rutherford Engine, the first oxygen/hydrocarbon rocket engine to utilize additive manufacturing for all primary components, setting a precedent in rocket technology. Present. Today, Rocket Lab is best known for its Electron launcher, which can deliver payloads of up to 150 kilograms to sun-synchronous orbits. The company has expanded its operational footprint, establishing a headquarters in Los Angeles while maintaining its launch site in New Zealand. The Electron program has revolutionized access to space by offering frequent and dedicated launch opportunities tailored for small satellite operators. In addition to its commercial success, Rocket Lab has engaged in public-private partnerships (PPPs) to enhance its technological capabilities. Collaborations with organizations such as NASA and the U.S. Air Force have allowed Rocket Lab to leverage advanced technologies and expertise, further solidifying its position in the aerospace industry. Technological innovations. Rocket Lab has pioneered several advancements in rocket technology, particularly through its use of additive manufacturing. The Rutherford Engine's design exemplifies this innovation, reducing costs and production times while enhancing performance. Furthermore, Rocket Lab's commitment to producing all technology in-house has fostered significant advancements in aerospace knowledge and capabilities. The company's focus on responsive launch services has also positioned it as a key player in the evolving landscape of space exploration. The ability to rapidly deploy small satellites has become increasingly important, and Rocket Lab's Electron rocket is tailored to meet these needs efficiently. Future. Looking ahead, Rocket Lab is poised to further revolutionize space access through several ambitious initiatives. The company plans to develop the Neutron rocket, which aims to support larger payload capacities for both commercial and government customers. This strategic move will enable Rocket Lab to compete with other companies in the growing small satellite launch market. Another critical initiative is the Affordable Responsive Modular Rocket (ARMR) program, which seeks to drastically reduce engine development time and costs. This project is designed to enhance responsiveness to emerging demands in space access, similar to the operational capabilities of unmanned aerial vehicles (UAVs). Additionally, the Rotating Detonation Rocket Engine (RDRE) is an innovative propulsion technology that Rocket Lab is exploring. This engine design promises to increase payload capacity significantly, offering a potential breakthrough in launch vehicle efficiency. Partnerships and collaboration. Both Rocket Lab and the U.S. Air Force Research Laboratory (AFRL) emphasize the importance of partnerships in advancing space technology. The AFRL has a storied history of developing propulsion technologies and has transitioned its expertise into new space launch vehicles through collaborations with various companies. The AFRL's initiatives, such as the Integrated Powerhead Demonstration (IPD) and Upper Stage Engine Technology (USET), highlight the laboratory's commitment to modernizing propulsion systems. These programs aim to enhance the performance and reliability of both military and commercial launch vehicles, reflecting a shared goal with Rocket Lab to achieve responsive and frequent space access. Key milestones timeline. 2006, Rocket Lab is founded in New Zealand. 2009, becomes the first private company to reach space from the Southern Hemisphere. 2014, announcement of the Electron launch program.
2016, initiation of Electron test program at the Mahia launch site. 2020, launch of the first operational Electron rocket, marking a new chapter in dedicated small satellite launches. 2025, anticipated introduction of the Neutron rocket and advancements in ARMR and RDRE technologies. Conclusion. Rocket Lab's journey from a small startup to a major player in the aerospace industry illustrates a remarkable evolution driven by innovation and strategic partnerships. With a strong focus on responsive launch services and groundbreaking technologies, the company is well positioned to shape the future of space exploration. The ongoing collaboration with organizations like AFRL further enhances its capabilities, setting the stage for an exciting era in space technology and exploration. As Rocket Lab continues to push the boundaries of what's possible in aerospace, its commitment to making space accessible will undoubtedly leave a lasting impact on the industry. Counterintuitive information in the content about Rocket Lab. 1. Public-private partnerships. While public-private partnerships (PPPs) are often viewed as a means for private companies to benefit from government resources and expertise, Rocket Lab's approach demonstrates that these partnerships are mutually beneficial. The Air Force Research Laboratory AFRL leverages its partnerships with companies like Rocket Lab to transition advanced technologies into the commercial sector, thus enhancing its own capabilities while simultaneously supporting the private aerospace industry's growth. This reciprocal relationship challenges the traditional view that government contracts primarily favor private enterprises. 2. Additive manufacturing advancements. It may seem counterintuitive that the use of 3D printing additive manufacturing in aerospace could lead to a more efficient and cost-effective production process, especially given the high stakes of space missions. However, Rocket Lab's Rutherford Engine, being the first oxygen/hydrocarbon rocket engine to utilize additive manufacturing for all primary components, exemplifies how this technology can streamline manufacturing and improve performance. The success of additive manufacturing in such a critical field highlights a significant shift in engineering paradigms where traditionally conservative industries embrace innovative techniques. 3. Commercial success versus government contracts. Many assume that government contracts are the primary source of revenue for aerospace companies. However, Rocket Lab has built a successful business model centered around providing launch services for the small satellite market. This focus on commercial customers has allowed Rocket Lab to thrive independently without being overly reliant on government contracts, which is often the lifeblood for many aerospace firms. This highlights a shift in the aerospace industry where commercial viability can drive innovation and growth just as much as government funding. For responsive space access, the concept of responsive space access might intuitively suggest a need for highly complex and costly systems. Nevertheless, both Rocket Lab and AFRL are pursuing strategies aimed at simplifying and accelerating access to space. The Affordable Responsive Modular Rocket (ARMR) initiative aims to reduce engine development costs and time significantly, showing that cost-effective solutions can indeed enhance responsiveness rather than complicate it. 5. Emerging technologies. The development of the rotating detonation rocket engine (RDRE) could seem like a radical departure that would introduce significant risk and uncertainty into rocket design. However, the RDRE's potential to increase payload capacity and reduce engine mass indicates that innovative approaches can yield more advantageous outcomes than traditional designs. This challenges the notion that established methods are necessarily the safest or most effective routes to achieving aerospace goals. 6. Small launch vehicles. It is often assumed that larger rockets are more capable and thus more desirable for satellite launches. However, Rocket Lab's success with its Electron rocket illustrates that smaller launch vehicles can fill a crucial niche in the market, catering specifically to the needs of small satellites. This shift in focus towards smaller dedicated launches has proven lucrative, contradicting the stereotype that larger is always better in the aerospace industry. 7. Global operations and local routes.
While many aerospace companies expand globally and move their headquarters to major commercial hubs, Rocket Lab has managed to maintain its connection to its New Zealand roots while establishing a strong presence in the US. This dual approach, combining local expertise with global reach, demonstrates that companies can successfully leverage their origins in a way that enhances their operations rather than dilutes their identity. 8. Technological evolution from military to commercial. The typical narrative posits that military advancements trickle down to civilian applications. However, the partnership between AFRL and Rocket Lab indicates a reverse trend where commercial innovations are influencing military capabilities. The ARMR and TRSA initiatives, while rooted in commercial needs for responsive access, are providing the military with advanced technologies that enhance their operational capabilities. In conclusion, these counterintuitive points illustrate a dynamic shift in the aerospace industry where traditional assumptions about government versus commercial interests, large versus small vehicles, and established manufacturing processes are being challenged by innovative practices and new business models. Rocket Lab's trajectory reflects a broader trend toward a more interconnected and responsive aerospace ecosystem. Important overlooked content in the Rocket Lab report. In the comprehensive examination of Rocket Lab, there are several nuances and details that many readers may overlook, which are significant for understanding the broader implications of Rocket Lab's developments and the future of space access technology. Here are key points that deserve particular attention. 1. Additive manufacturing in rocket propulsion. The development of the Rutherford engine stands out as a significant technological advancement due to its reliance on additive manufacturing for all primary components. While many readers may recognize the engine's capabilities, the implications of using 3D printing in rocket engines often go unexamined. The significance of this innovation lies in its potential to revolutionize not just production efficiency but also design flexibility. Why it matters: additive manufacturing allows for more complex geometries that traditional manufacturing methods cannot achieve. This can lead to lighter, more efficient engines that reduce launch costs. Additionally, the ability to produce components on demand can significantly shorten lead times, enabling rapid prototyping and development cycles. 2. Public-private partnerships (PPPs). The emphasis on public-private partnerships, especially in the context of the Air Force Research Laboratory (AFRL), is a critical aspect that may be overlooked. While many reports highlight Rocket Lab's commercial success, the collaborative framework of PPPs is essential for nurturing innovation in propulsion technologies. Why it matters: these partnerships allow for the sharing of resources, expertise, and technological advancements, facilitating a faster development timeline for critical technologies. This model not only enhances Rocket Lab's capabilities but also strengthens national security by ensuring that cutting-edge technologies are developed and maintained in the U.S. and allied nations. 3. Responsive space access initiatives. The focus on responsive space access technologies such as the Affordable Responsive Modular Rocket (ARMR) and Tactically Responsive Space Access (TRSA) may not receive the attention it deserves. Many readers may view these as just additional projects, however, their implications for military and commercial applications are profound. Why it matters: the shift towards rapid on-demand launch capabilities could transform military operations, allowing for quick deployment of satellites or payloads in response to emerging threats. This responsiveness could provide a strategic advantage in conflict scenarios, emphasizing the importance of space as a critical domain in modern warfare. 4. Rotating detonation rocket engine (RDRE). The exploration of rotating detonation rocket engines is a potentially groundbreaking area of propulsion technology that might not be fully appreciated by the general audience. The transition from conventional combustion to detonation-based propulsion represents a significant leap in engineering. Why it matters: RDREs promise higher efficiency and potentially lower costs for launching payloads into space. Understanding the physics behind detonation waves and how they can be harnessed for propulsion may lead to significant advancements in both military and commercial applications.
The implications of such technologies could redefine payload capacities and operational costs.
5. Historical context of technology development. The historical narrative surrounding the development of propulsion technologies, particularly those stemming from the AFRL, provides valuable insights into the evolution of the aerospace sector. Many may not connect the dots between historical advancements and current technologies employed by Rocket Lab. Why it matters: recognizing the lineage of technology helps to understand the iterative nature of innovation in aerospace. The historical context of propulsion systems developed for ICBMs and how they have transitioned to modern launch vehicles highlights the importance of a robust research and development infrastructure,
which is crucial for future advancements. 6. Global expansion and market dynamics.
Rocket Lab's decision to establish its headquarters in Los Angeles while maintaining operations in New Zealand is not merely a logistical move, it reflects a strategic response to global market dynamics. Many may overlook the significance of this expansion in the context of competition and collaboration in the aerospace sector. Why it matters: the establishment of a presence in the U.S. allows Rocket Lab to tap into the vast American aerospace market and engage with key stakeholders including government agencies and major defense contractors. This positioning is crucial for securing contracts and partnerships that can drive future growth. 7. Cultural and community engagement. The potential community engagement efforts and educational outreach by Rocket Lab are often overshadowed by technical discussions. However, fostering a community around aerospace innovation can have long-lasting impacts on public perception and interest in space exploration.
Why it matters: by engaging with local communities and educational institutions, Rocket Lab can inspire the next generation of engineers and scientists.
This cultural shift towards valuing STEM education is vital for sustaining innovation in the aerospace sector. 8. Environmental considerations in launch operations.
While not explicitly detailed in the report, the environmental impact of rocket launches is an increasingly critical topic. The advancements in Rocket Lab's technology could have implications for sustainability in the aerospace industry.
Why it matters: as space launches become more frequent,
the environmental footprint of these operations will come under scrutiny.
Innovative technologies that reduce emissions or enhance the sustainability of launch operations will be crucial for the industry's long-term viability and public acceptance.
Conclusion:
Rocket Lab's journey from a small startup to a major player in the aerospace industry encompasses a range of technological advancements, strategic partnerships, and market expansions. By paying close attention to the overlooked aspects discussed above, stakeholders can gain a deeper understanding of not only Rocket Lab's trajectory but also the future landscape of space exploration and technology. These insights highlight the importance of innovation, collaboration, and responsiveness in an increasingly competitive and rapidly evolving industry. Key points for in-depth analysis and discussion on Rocket Lab: past, present,
and future. 1. Technological innovations and achievements.
Rocket Lab's development of the Rutherford Engine is a significant milestone in rocket propulsion technology. It is distinguished as the first oxygen/hydrocarbon rocket engine to utilize additive manufacturing for its primary components. This innovation not only streamlines production but also enhances performance and reliability. The emphasis on additive manufacturing represents a broader trend in the aerospace industry toward more efficient and cost-effective manufacturing processes. The success of the Electron launch vehicle, which leverages this technology, underscores the critical role of innovation in establishing a competitive edge in the commercial space launch market.
2. Market position and strategic growth.
Rocket Lab has carved out a niche in the small satellite launch market, providing dedicated and frequent launch opportunities. The Electron launcher, capable of carrying payloads up to 150 kilograms, has positioned Rocket Lab as a key player in an industry that increasingly values responsive and tailored launch services. The establishment of a global headquarters in Los Angeles alongside the launch site in New Zealand reflects strategic growth to enhance operational capabilities and reach a broader customer base. Public-private partnerships (PPPs) have been integral to Rocket Lab's strategy, enabling collaboration with government entities and leveraging advanced technologies to improve launch services.
3. Future initiatives and ambitions.
Looking ahead, Rocket Lab's development of the Neutron rocket aims to increase payload capacities and expand its service offerings to both government and commercial clients. Additionally, initiatives such as the Affordable Responsive Modular Rocket (ARMR) and Tactically Responsive Space Access (TRSA) highlight the company's commitment to revolutionizing space access. These programs focus on reducing development costs and timescales, which could enhance the frequency and responsiveness of launches.
Much like the operational flexibility seen in UAV deployments,
the pursuit of rotating detonation rocket engine (RDRE) technology also indicates a forward-thinking approach to propulsion, promising greater efficiency and payload capabilities.
4. Comparative analysis with AFRL. The parallel advancements made by the Air Force Research Laboratory AFRL present an interesting comparison.
While Rocket Lab focuses on commercial launch services and the small satellite sector, AFRL emphasizes military and advanced propulsion technologies. Both organizations emphasize partnerships as a means to enhance capabilities, but their objectives differ. Rocket Lab aims for market competitiveness and innovation in commercial services, while AFRL seeks to strengthen national defense through advanced space technologies. The collaboration between these entities may lead to synergies that benefit both the commercial sector and defense applications, particularly in responsive space access and propulsion innovations.
Conclusion.
The trajectory of Rocket Lab from a startup to a significant player in the aerospace sector reflects its focus on technological innovation, strategic market positioning, and forward-looking initiatives. The collaboration with AFRL further enriches the landscape of space exploration and technology, paving the way for exciting developments in the years to come. These key points provide a framework for further discussion and analysis of Rocket Lab's impact on the aerospace industry and its future direction. 1. SpaceX, the rise of a commercial space power. Founded in 2002 by Elon Musk, SpaceX aimed to reduce space transportation costs and enable the colonization of Mars. The company made history by launching the Falcon 1 in 2006, becoming the first privately developed liquid-fueled rocket to reach orbit. SpaceX's development of the Falcon 9 and Falcon Heavy rockets, along with the Dragon spacecraft, has transformed the commercial space industry, leading to numerous contracts with NASA and other organizations. SpaceX has pioneered reusable rocket technology, significantly lowering the cost of access to space and setting new standards for launch frequency and reliability. 2. Blue Origin, Jeff Bezos's vision for space exploration. Founded in 2000 by Amazon founder Jeff Bezos, Blue Origin is focused on building a road to space for millions of people. The company has developed the New Shepard suborbital vehicle, which successfully completed its first crewed flight in July 2021. Blue Origin also aims to build a lunar lander called Blue Moon for NASA's Artemis program. The company emphasizes reusability, having designed New Shepard to be fully reusable after each flight. Blue Origin's efforts are part of a broader vision to enable a future where millions of people can live and work in space. 3. Arianespace, the first commercial launch provider. Established in 1980, Arianespace was the first company to offer commercial launch services using the Ariane rocket family. Arianespace successfully launched its first Ariane 1 rocket in 1979, marking the beginning of commercial spaceflight. The company has played a pivotal role in the development of the European space industry and has provided reliable launch services for a variety of payloads, including satellites for telecommunications, Earth observation, and scientific research. Arianespace's commitment to innovation and reliability has made it a key player in the global launch market for over 4 decades. Future outlook, Rocket Lab's trajectory. Introduction. Rocket Lab, established in 2006, has evolved significantly within the aerospace sector, particularly in the small satellite launch market. With a successful past and a strong present, the company is poised for exciting developments in the future. This outlook will explore key predictions regarding Rocket Lab's innovations, business strategies, and market dynamics over the next decade. 1. Advancements in launch vehicles. Rocket Lab is set to enhance its launch capabilities with the introduction of the Neutron rocket, which is expected to provide higher payload capacities compared to its current Electron rocket. Neutron is designed to carry larger satellites, including those for government and commercial sectors. This expansion into medium-lift launches will allow Rocket Lab to compete with larger players like SpaceX and Blue Origin, tapping into a broader market segment that demands heavier payload launches. 2. Focus on reusability. The trend towards reusability in rocket technology is likely to continue shaping Rocket Lab's strategy. Following the success of its Electron rocket, which has seen multiple launches, Rocket Lab may adopt and refine reusability features for the Neutron rocket. By reducing costs and turnaround times through reusable components, Rocket Lab can further enhance its competitiveness in the launch market and achieve economies of scale. 3. Responsive launch capabilities. The concept of responsive launch capabilities will be a cornerstone of Rocket Lab's future developments. With initiatives like the Affordable Responsive Modular Rocket (ARMR) and Tactically Responsive Space Access (TRSA), the company aims to enable rapid on-demand launches. This approach aligns with military and commercial needs for quick deployment of satellites and other payloads, indicating a strategic pivot towards a more agile space launch service. 4. Increased partnerships and collaborations. Public-private partnerships (PPPs) will likely continue to play a crucial role in Rocket Lab's growth. Collaborating with government agencies, defense contractors, and other private companies will facilitate technology sharing and accelerate the development of innovative launch solutions. Such partnerships could also enhance Rocket Lab's access to funding and resources, enabling it to stay at the forefront of aerospace technology. 5. Emphasis on advanced propulsion technologies. Rocket Lab is expected to invest in advanced propulsion technologies, including the development of the Rotating Detonation Rocket Engine (RDRE). This technology promises to improve efficiency and payload capacity significantly. By focusing on cutting-edge propulsion systems, Rocket Lab can position itself as a leader in the next generation of space exploration and satellite deployment technologies. 6. Expansion of global launch sites. To accommodate increasing demand, Rocket Lab is likely to expand its launch facilities beyond New Zealand and the US. This expansion could involve establishing new launch sites in strategic locations around the world, enabling the company to offer more flexible and accessible launch options for international clients. 7. Growth in the small satellite market. The small satellite industry is expected to continue its rapid growth, driven by increasing demand for satellite-based services, such as communication, Earth observation, and scientific research. Rocket Lab's focus on small satellite launches positions it well to capitalize on this trend. The company may expand its offerings by providing additional services such as satellite integration and deployment solutions, catering to the needs of small satellite operators. 8. Sustainability and environmental considerations. As the aerospace industry faces increasing scrutiny regarding its environmental impact, Rocket Lab may prioritize sustainability in its operations. This could involve developing greener propulsion technologies, minimizing waste during rocket manufacturing, and implementing environmentally friendly practices in launch operations. Emphasizing sustainability can enhance the company's reputation and appeal to environmentally conscious clients. 9. Adaptation to regulatory changes. As the space industry evolves, regulatory frameworks will also change. Rocket Lab will need to stay ahead of these changes, adapting its operations to comply with new regulations governing space traffic management, satellite launches, and space debris mitigation. Proactively addressing these regulatory challenges could position Rocket Lab as a responsible leader in the aerospace sector. 10. Long-term vision for space exploration. Looking further ahead, Rocket Lab may aim to contribute to broader space exploration initiatives including lunar and Martian missions. By developing technology that supports interplanetary transport and collaborating with space agencies on exploratory missions, Rocket Lab could expand its role beyond commercial launches and into the realm of deep space exploration. Conclusion: Rocket Lab's trajectory from a small startup to a key player in the aerospace industry has set the stage for an exciting future. Through advancements in launch technology, a focus on reusability, responsive launch capabilities, and strategic partnerships, Rocket Lab is well positioned to thrive in the evolving aerospace landscape. The company's commitment to innovation, sustainability, and adaptability will be crucial as it navigates the challenges and opportunities of the coming decade.